In this circuit, the unknowns are V1, this voltage, I1, the current through this resistance, and V2, this voltage. So I want to solve these unknowns using node voltage method. So node voltage method, I will introduce node voltage method using this example. That probably is a good idea. So node voltage method is something like this. First we try to identify how many nodes are there, and then assign a voltage to those nodes. If there are 3 nodes, not all of them, just 2 nodes will be assigned with unknown voltage, and 1 node will be assigned as the reference node or ground node, which will have the voltage 0. So other nodes, the unknown ones, will have the voltage according to that reference node. So for this particular circuit, we can see there is one node here, there is one node here, and there is one big node, which is this one. So there are 3 nodes in total. So while assigning the reference node, it's always wise to select the node that has most branches connected to it. That is the best way, because then we will end up having less quantities in an equation, not less number of equations will be same. So basically here in this case I will assign this node as the ground node, so this one will have 0 volts. This node, let me call this one, we already have the voltage of this one, since the drop here is V1 and this one is 0 volts, so this node's voltage will be V1. Similarly, if we look at this node, the voltage will be, since there is this drop V2, so the voltage will be V2. Since from 0 here to a rise of V2, so the voltage here will be V2. So we have assigned the unknown node voltages. And now what we will do is we will write KCL equations for each of those nodes, Kirchhoff's current law equations. So we will assign current to each of the branches. So now this branch has a current which we know 15 amps, because that is a current source. So we know it's an entering current which is entering into this node. Now what we need is, we will write the current in the node, we will write the current as the outgoing currents as positive. That's a better way to represent it. So any current that is outgoing will be positive. So 15 amps will be negative, since this is an incoming current to the node. Then we will consider the current that is going away from here. Now this one is a current that we are just assigning. And how do we write that current? Because this branch this is a resistance, so the current can be written from Ohm's law. We know the voltage here, V1. So the drop across this 60 ohms resistance is V1. So we know that. So the current will be, since it is going away from the node, it will be V1 over 60. Similarly, the current through the 15 ohms resistance, this one will be V1 over 15. So that will be V1 over 15. And then we have the final current, which is this one going away, which is also I1, but instead of writing I1, I will write in terms of voltages. That will be better. So that will be, the voltage here is V1, the voltage here is V2. So the voltage difference is, the current is going in this direction, so the voltage, the drop across 5 ohms is V1 minus V2. So V1 minus V2 is the drop across 5 ohms resistance, divided by 5 is the divided by the resistance, that's Ohm's law, that's the current. So sum is 0. So what I have done, I have written KCL for V1, node V1, and I have assigned the outgoing currents as positive and the ingoing currents as negative. There was only one ingoing current, so that's negative there. So now I can rewrite this one. I can write V1 over 60 plus V1 over 15 plus V1 over 5 minus V2 over 5 is equal to 15. So we have that now. Now what I can do, I want to get rid of the fraction, so I will multiply both sides by 60. So I will get V1 For the second one I will get plus 4v1. For the third one I will get 12v1, and for the final one, which is this one, I will get minus 12v2 is equal to that 6300. So my voltage equation is 17v1 minus 12v2 is equal to 6300. That's equation 1. So I have that now. Now I will write the node KCL equation for the second node, which is V2, this one. So again I have this current. Now I will assign the same current in this direction, just for writing it, because I am assigning all the currents at outgoing currents. The outgoing currents as positive, but if I have any incoming currents in terms of the current source or something, I will write it negatively. Negative. So this one becomes, for the node for the second node, node 2, the node voltage equation is V2 minus V1 now, outgoing current, since the current is outgoing, V2 minus V1. Then I have this current which is outgoing, and the voltage drop is this one, which is V2. So V2 over 5, and of course it has to be V2. This is V2 and this is 0 here. This one is 0, the ground. So V2 over 2, and then finally the current source is also outgoing, so plus 5. So that's there. This resistance is 2 ohms, so this should be 2, sorry. So that is 2 there. So V2, what I will do, I will multiply by 10, so it will be 2V2 minus 2V1 plus 5V2, and then 10, so that's 50, so negative 50, taking on the right hand side, so just 50, not 150, so like that. So this is now minus 2v1 plus 7v2 is equal to minus 50. I hope the equation is correct. So what I have two equations. So what I will do, I will multiply equation 1 by I want to get rid of the v2, so I will multiply this one by 7 and the second one, equation 2, by 12. So this one will be by 7. So I am getting 119 v1 minus 84 v2 multiplying by 7. And actually what I did the right hand side wrong. It should be 15 times 60, so that will be just 900, not 6300, so that will be 900 there. What I did is I did this problem earlier and I did multiply. Now it will become 6300, so I just looked it wrong. I was looking it up and I looked it up wrong, sorry about that. So this is 6300 now after the multiplication by 7, because I am multiplying equation 1 by 7 and 2 by 12. So this is minus 24 v1 and this one will be plus 84 v2. The purpose of multiplying is just getting rid of v2, and this one is now becoming, that's the negative, and that will be 12 times 5, 600, so minus 600 basically. So now I will just add them, because I have the signs negative here, plus here. So once I add them, I will get, so that's 95 v1 and v2 is getting cancelled, and this is 5700, so v1 is becoming 60 volts there. So that's there. V1 is now I have. Now I want to get V2, so I will use equation 2, which is 7V2 here, and then this one is minus 50. So I will just write what will be V2, so that will be like that. And once I do it, so I get V2 as 10 volts, so that's there. This is also known now. Finally I have to find what is I1, so that is V1 minus V2 over 5 V1 minus V2, because the direction of the current, if we remember, it is actually going from in this direction, that means V1 is at a higher potential. So yeah, so this is 60, this is 10 over 5, so that's 50 over 50, which is 10 amps finally. So these are the three quantities. This video has been long, but most of this is actually the calculation. So yeah.